Great. Well, thank you everybody for getting to the last session, or at least the last one session. I hope you'll stay for the wrap up, which will be after this. I don't know whether it makes you happy or sad to be still here, but actually, I'm sad that it's the last one because I've enjoyed everything that I've seen, and I hope you have too. So the last session is Tony Salmi from CGI, and I notice his CGI colleagues are out here in force as well to support him. So the CGI crew is here. So Tomi is a senior solutions architect with 25 years experience in GIS and remote sensing and all that entails. He's a lead solution and data architect in projects delivered for the Finnish Food Authority, which is what he's going to be talking about today, working on the land parcel information system, satellite monitoring and other GIS projects. So Tomi, over to you.
Oh, thank you. So basically today I'm going to talk about how Finnish Food Authority use FOSS4G software in different part of the CAP process. So one corporate slide. So CGI is a large company globally, over 90,000 people, but for this we have over 700 geospatial experts, about 100 here in UK and about 100 in Finland, so where this project has been going on since 2000. So today's agenda, first few words, what is actually CAP, and then going through how Finnish Food Authority tackles the EU CAP process, and then we are going to dive into the different parts of the process and what kind of FOSS4G software is used in those processes. So what is CAP? So basically it's common agriculture policy, so something that EU demands from each EU member state. And basically it's the framework for the agriculture, rural development and sustainable land use. And what it actually means, it's how the direct subsidies are paid to the farmers and what the government has to do and how they basically control that subsidies are paid to the right amounts, the right farmers. And in the GIS part, it's almost all subsidies are paid using the exact parcel area. So a lot of digitizing of polygons where the parcels are. And every CAP in the EU has just involved more GIS related things. So many data sets have to be used, geospatial activities have to be done. So this whole process can't work if we are not using GIS software. And there's a lot of in one slide, but basically just go the overview how the yearly circle is going. So first the farmers are doing the geospatial applications. So basically it's a web portal where they do the subsidy applications. And they basically introduce, maybe they have to digitize the parcels, then they're going to introduce what crop they are going to growing this season. And this information goes to the LPs where the actual digitizing is done. So using the current orthophotos, we make sure that all the parcels are digitized as expected. And in the latest EU CAP, they introduced the satellite monitoring system. So basically each member state has to have a satellite monitoring system using Sentinel-1 and Sentinel-2 data and a lot of machine learning to actually try to minimize the on-the-spot controls and do it automatically using satellite data. And of course, there are always the administrative users that actually going to decide, are we going to pay the subsidies to the farmers? And if there's something wrong in the application, send request for information for the farmers. And in the center is the Ajax system. The first one is the VIPU service and EAX application. So the VIPU service is what are the farmers using to make the geospatial aid applications. So it's a browser-based portal where they input all the information for that year's aid application. And the central part of that is the leaflet-based map applications where they can digitize their new crop parcels, reference parcels. And of course, because the EU, there's a lot of regularities how you have to, what can you actually grow and what different kind of things or activities you have to do during the year. And that's why there's a lot of wizard style helpers for the farmers. So when they are doing the application, they are calculating things. Have you done the aid application correctly? And for the administrative users, basically they are using the same leaflet-based map application, but of course they can see all the subsidy informations and they made the final decisions, are the subsidies going to pay to the farmers. And also they see all the information from the satellite monitoring system. So basically traffic light based informations. Is there something wrong with the application? For example, the satellite monitoring system can see that the parcel is not homogeneous, or it seems that the crop is different. That was what was input in the aid application. And on the server side, still all the data is in Oracle Spatial, but at some point we are slowly moving to PostGIS. So when the government has the money for that one, but it's happening at some point. And GeoServer and MapServer, just for the standard OGC. Basically, the MapServer will at some point disappear, so we are just going to use GeoServer. But at the moment, MapServer and the GeoWebCats are where we, for example, when we have all the nationwide orthophotos and everything is tiled, so we can access the data fast to the farmers. Here's a one screenshot about the leaflet part, and basically for the administrative users, they can also use this application on the field. So basically in a tablet with GPS, so they can do the on-the-spot inspections with this one. And the next part is the land parcel identification system, and CGI has been the main contractor maintaining this one since 2000. And basically that's the system where all the reference parcels and the crop parcels inside are digitized on top of the latest orthophoto. So in Finland, we have 1 million reference parcels and about 300,000 of them are processed annually. And from those 300,000, about 100,000 are actually digitized. So basically there's a 3-year cycle that EU demands, that you have to get new orthophotos and basically go through the whole country in 3 years. And there's 3 kind of corrections that we digitize. The farmer corrections comes from the geospatial aid applications. The inspection corrections are the one that the administrative users are doing either on the spot, on the field, or using the Ajax application. They say there's something wrong with the application and they change the digitizing. And the LPIS is the place where we actually do the final digitizing. And a big part is the updated digitizing. So every year we get new orthophotos. We have to do pre-selections which parcels we actually going to digitize. So for that we have implemented a computer vision system, basically tries to segment the parcel, the crop area from the orthophoto, and if everything seems to be okay, then it doesn't need to be digitized. And for the LP system, we are currently doing the first iteration to move from the proprietary map info, map basic Oracle spatial system, which was actually implemented in 2000. So it's really old stack and has been working fine. And there's a lot of logic inside the Oracle spatial database, a lot of PL/SQL code. So basically there's no application server in the middle. So logic is either in the, we probably have the biggest map basic software ever made. I don't think that's a good or bad thing, but it's probably something that has happened. And then we are using JDAL to actually cropping the orthophotos and other data sets to the computer vision systems. And the first iteration we are currently doing is doing a Python plugin for QGIS. And the first iteration we'll still be using the Oracle Spatial database, but basically there's going to be an application server which handles all the access to the database, and we move some logic from the Oracle Spatial to the application server, and all the map layers are get from through the GeoServer normal API, so no direct calls to the database or using local map files. And the next iteration hopefully will start year 2 is going to replace the Oracle Spatial with the PostGIS database, which will be quite easy because now we have implemented the application server level, so we can basically just switch the database. And of course, there's still going to be a lot of logic on the database level, but less than currently. Few words about the satellite monitoring system. So basically, it's implemented in AWS using Sentinel-1 and Sentinel-2 data from the ISAS CDSC, which was today said it's a really bad platform to access open data. And in the end, there's maybe few dozen machine learning models which are calculating different things from the satellite data and basically giving answers to those 9 questions that FFA has decided. For example, is the parcel homogeneous? Is the parcel's crop parcel the one that was actually in the data application? And the system is giving traffic light type answers to those 9 questions, and the client is using those to maybe request some more information from the farmers, or basically just deny that they are not going to pay the subsidies. But today we are just going to talk about the right part where we are basically using another QGIS plugin expert application to actually visualize the results and something about how we gather the ground truth data. So basically, the application is called expert application, and basically the administrative users are using this one to visualize what are the results from the satellite monitoring system, and they can manually change the traffic lights if needed. So it's another Python implementation, and it's tightly integrated to the client's IAM system. So basically, what data they can see, if it's actually a county administrative user, they can only see the data from that county, and do they have right to actually change the traffic light answers. Standard map layers and a lot of implementation actually visualizing different kind of markers and signals, what we have done using the machine learning model. So vegetation indexes and things like that, how we actually get the actual final traffic light results. GeoServer is used for the normal map layers and also getting the Sentinel-1 and 2 data from the CDSC. And also visualizing the traffic lights on the top of the map. And the PostGIS database has all the crop and reference parcel geometries, and also the pixel bounding box for all the Sentinel images, because basically how we do the machine learning part, we are trying to analyze each pixel that's inside the crop or reference parcel. So one screenshot about the application. So basically we can look different kind of a time series. How was the Sentinel-2 data? For example, we had too many clouds, which means quite awful timeline series for the machine learning model. And then basically they can visualize each parcel and all the indices that have been calculated, all the markers for each of the parcels. And if the user has enough rights, they can change the traffic lights, for example, from green to red. So green means that they are going to pay the subsidy, they have the right answer. For example, the parcel is homogeneous. And then finally, QField and QField Cloud. So luckily our client understood how important the ground truth data is. So basically they started the project in 2020, and back then we did 3 collection drive-through. So basically what was the actual crop on the field. But since 2002, we are driving through 1,800 parcels each week. So there's 16 different routes made for the ELU centers, and basically they are weekly going through all the parcels and basically just giving how the crop looks like or how the soil looks like, and basically is some activity being done on the field, mowing or plowing or ripening or something else. And this is really crucial that we can actually train the machine learning models and in the end validate the results. So without this data, I don't think the system wouldn't work as well as it's currently doing. And because even the QField Cloud is a open source software, I have to admit it wasn't that easy to actually install and make a Docker container because the documentation was quite short and didn't actually work. But after bouncing our head to the wall at some point, now we are running a Docker container where the QField Cloud is working, and basically the client are in the future going to different departments inside the Finnish Food Authority want to use the QField Cloud. Now we know how we can make more instances for different departments. And for the QField, basically there's 16 ELU centers in Finland. Each of them has their own QField Cloud project. So before they start driving the weekly route, they download the QField project, and it basically contains all the parcels, visualize what was the last week's data and in which way they have to drive. And then when they are driving through the parcels, there's a few selections they can choose. And so really quickly they can drive through the whole route, and then they just upload the whole project back to the QField Cloud. And then we are doing some steps on the PostGIS side to actually copy the data to our time series database. And that's the series we are then using for the machine learning training. I think we are missing one slide. Oh, yeah. I also mentioned the Ajax and ELPIS. They are basically something that each EU member states have to have. The Ajax is where you actually have all the attribute data about the farmers, farms, parcels, and how you pay the subsidies. And that's governed by the Finnish Food Authority. And the ELPIS is the one GIS database where you have all the parcels. Okay, that's it. Thank you.
Thanks so much, Tomi. Do we have any questions? I've got one to kick off, and that is, that's all fine. It's an interesting story, and obviously it's large scale application, lots of work. You mentioned, I think the only thing that you said was maybe a bit tricky was the QField documentation. Were there any other challenges that you had? Were there things that were more difficult than you thought? Were the points that you thought, why are we doing this? Or was it all kind of a nice smooth process?
Basically, we probably have done 10 different projects for the Finnish Food Authority. We have done the previous versions of before the leaflet, there was another open source GIS. So basically, for the ELPIS, now it goes smoothly, but I can say the year 2000 when we started, that wasn't easy year, but
it was a hard year for everybody.
Yeah, but basically I actually saw the original paper, so the work estimate. Somebody said, okay, we just use mapping for, we have a live connection to the database, 10 days to make a digitizing software. We can, you didn't know the parcels inside parcels and things like that. So basically that 10 days was probably 200 or 300 in the end. But I think for the satellite monitoring, we had nice pilots with the client because they started really early. So we had first pilots maybe 7 years ago, trying different companies, try what kind of machine learning models even work, what can we do with the Sentinel data. And when we actually went to the production, the AWS side, I think that was the easiest part. So I think the trickiest part was to make the machine learning models actually work. And because I think in today's presentation there have been like for make the satellite monitoring project work, we need 3 kind of people. We need the IT guys who can do the cloud part. That's the normal IT stuff. They know how to make Docker containers. And then we need the machine learning guys who maybe know how to train the machine learning, but they probably don't know anything about agriculture or farming or anything. So luckily our client, Finnish Food Authority, most of them are actually farmers themselves. So we have a lot of expertise from their side, how it actually looks on the field. And that helped really a lot, that we actually chose the right topics to actually tackle with the machine learning models. So
you need farmers on board.
Yeah,
that's the message. Go ahead.
As I understand it, the farmers are interacting directly with the system. Do they love it? And in particular, I can imagine a farmer having 3 fields with the same crop and saying, I only want to do this once.
Yeah, so the question is how the farmers like the system. So to be honest, even in Finland, most of the farmers, they are not that IT savvy guys, but luckily there are a lot of companies who provide services. So the farmers don't want to do the geospatial application by themselves, so they are using some company to do that. But I think most of the part, they actually over the years they get used to it. And basically, if nothing changes, like you are not doing any new parcels or anything. Basically, you get the last year's data as a start. So if you only have to, maybe you are using some other crops this year, you basically just have to fill the attribute data. But if you have to digitize something, it's not easy.
They get their 12-year-old daughter to do it.
Yeah, probably. And for the satellite monitoring, of course, just government is spying us now. They want to know what we're actually doing. But I think because one of the part they have this mobile application, so when the satellite monitoring system has analyzed the whole growing seasons, basically they are sending requests for information. Hey, you didn't mow your grass this year because the last date was last day of August. And sometimes the farmers they just forget to actually do it. So some of them are actually happy that they get a kind notification maybe 2 weeks ago, but some of them don't like it. We have seen pictures where had them certain figures in the on the crop fields for the satellite monitoring system. Yeah.
You didn't show us that.
No.
Okay. Any other questions?
Yeah.
It's a general question about cloud masking in general. So I imagine cloud masking is a problem in the UK. I imagine it's equally a problem in Finland. So how are you dealing with sort of basically incomplete data sets or figuring out what data sets is sensible to really use?
Okay.
So I imagine you can go for a whole year, be incredibly unlucky with no data for a year.
Yeah, okay. The cloud masking was the question, and how if we don't have enough data. So basically, first year we used the cloud masking that you get with the Sentinel data. That wasn't good enough. Next year we were actually using the Finnish meteorological office, like a Met office in here, and didn't work. And now we are actually using the Kappazeta, is the Estonian company. They actually made a better cloud masks. But even that one is not perfect. So basically, even though we have a traffic light, so three normal colors, but then we have black and blue, and they are basically not enough data. The parcel is too small, because that's one of the problems, because basically we only want to analyze the whole pixels inside the parcel, and sometimes the parcels are too small, or 45 degrees or something. We don't get enough pixels inside that one parcel, so then it just can't do anything about it. So, and then the client can manually change the traffic lights to green, for example. If they're okay, come on, the parcel are too small, then we are just going to pay the subsidies.
We're looking at a combination of cloudless and
Yeah,
cloud
yeah, yeah. I think the biggest problems are actually the cloud. So it seems to be the same problem in UK and Finland. And that's why we have to use the SAR data, but it's not, the optical data is better, but sometimes we have to make the time series using the SAR data, but yes.
Good. Any more questions? Okay.
Yeah. Yeah, the question was how long it made to implement this, how big our team is. Basically, I think what I went through there basically was 4 different projects. For example, for the LPS one, where we actually digitizing the parcels, there are probably 20 people working in that one. Most of our actual digitizers, but and for the satellite monitoring system, at the key point when we actually implemented, there was over 20 people doing for that. Maybe 5 to 10 people actually doing the machine learning part, and then the AWS cloud infrastructure guy doing that one. And then, so it's a lot of work, and it, luckily the Finnish Food Authority has been always quite prominent to use GIS. So since 2002, I have been working with them. They have always tried to use as much GIS as possible, and basically they are always one of the first countries in EU that start to use the different GIS technologies. So it's, and in the end, I think we are one of the countries who haven't got any big sanctions from EU, because basically everything is done correctly. Because the sanctions can be is the percentage of the whole subsidy payments. So if the subsidy payments are about 2 billion, basically if you get sanctioned, it can be 100 million euros. So some countries have done that. So
Great. Oh, quick question, and then we need to wrap up.
Yeah, just building on that sanction bit, 'cause that's
yeah,
a big driver for the Welsh rural payments team as well. How did you manage to convince them to go to open source and apply it to you because of the sanction issues? That's a bit we struggle with.
the question also about the FOSS4G software. I think for the LPS one, back then there wasn't much open source. So mapping for Oracle Spatial was maybe the main choice back then. But after that one, when they started to implement the web-based maps and everything in the services, there it was always that we have to do it in open source. And there are actually in Finland, there's a lot of few guys in OSGeo that run the Finnish one, and they actually work for the Finnish Food Authority. So there was some insight with that.
Yeah.
So that's why they started to use GeoServer and MapServer in the early days. So yeah.